Hello, I got a question about Constraint Manager and PCB Editor. All right, so I'm going to generalize this video and also demonstrate to you how to use Constraint Manager and PCB Editor. But we're going to start from the bird's eye view. When you're designing a printed circuit board, if you put traces like on this board, if you put traces too close to each other and you're putting connectors on the PCB and all of that stuff, if you put them too close together or too far apart or in the wrong way and things like that, you have to redo your design if it doesn't work properly. Now we can do that redesign ahead of time. We can design it in such a way that we maintain certain clearances and we maintain certain spaces and line widths and what width does the trace have to be and all of these questions. There are rules that we need to design by in order to make sure we don't do extra work or redo work. Constraint Manager is the application. It's the tool that helps you apply those rules at all times in your PCB layout process. Once you play by those rules, whether they're electrical, physical, spatial, and whatever else, once you play by those rules using Constraint Manager, you don't have to redo your work. Okay, the benefit of the Constraint Manager is to help you design by the rules set by multiple people and multiple stakeholders in the PCB design process, including your manufacturer, so that by the time you submit your printed circuit board design, you don't get a bunch of issues back. And by the time you get it fabricated and made and in your hand, you don't have more issues that could have just been solved if you had done something, moved something closer to the other thing or moved something further apart from the other thing usually. So that's the general purpose of Constraint Manager. Now that we understand the purpose, how do we use a Constraint Manager in any ECAD tool to our advantage? Well, I'll demonstrate that to you in PCB Editor. First, you want to go to your manufacturer's website. So whoever you're using for your manufacturer, whether it's, I could throw out some names, PCB Way, Sierra Circuit, so on and so forth. You want to look at their capabilities. Usually you'll find it in abilities, capabilities, whatever it's called on their website. Let me give you an example. So if we go to PCBWay.com, right? You look at product and capabilities. Then they will tell you, what does the board thickness need to be? Or what does the minimum trace width need to be? The copper layer thickness, the solder mask expansion, so on and so forth. Some of them even have guides. By them, I mean manufacturers. If you go to Sierra Circuits, they have this really handy guide called the Sierra Circuits DFM Handbook. And this handbook is just fantastic. Let's see if I can pull it up here. This is the DFM Handbook. The link is in the description below. So you download this handbook and it tells you what the trace width needs to be, what the minimum spacing needs to be. This is what your well, I wouldn't say needs to be. This is what your manufacturer is capable of doing. You actually calculate these numbers using things like an impedance and trace calculator, how much current you need. So really you design those things and then you go to a manufacturer that can make it for you. Right. Once you have your values like how much your trace width needs to be, how much spacing you need for voltage withstanding for the traces, how far they need to be apart to avoid coupling, how much clearance there needs to be between traces and between components, creepage, and all those things. Once you have those numbers, you go to your ECAD software, in this case, OrCAD PCB Editor. Then you go to Setup, Constraint. And when we go into Constraint, well, first of all, I'm going into Constraint Modes to give you a better idea of what I'm talking about. We have design. We have electrical constraints. Do we want to check for certain types of constraints in the electrical realm? do we want to check for certain physical constraints, right? And if you hover over here or you click the eye, you should get a summary of what these mean. So I'm just going to expand this. You click on this little thing to expand it, and then you check the minimum width of cline segments. Cline is short for connect line. I really wish they had some pictures here, but you see the properties of what's being described here. That's the physical constraints. Very important. Physical constraints have to deal with anything physical. The copper traces, how thick they need to be. The PCB material, how thick that needs to be. Spacing. When people talk about clearance and creepage and all that stuff, they're talking about spaces between things. So here we have a nice little graphic. The edge of the trace to the edge of the trace spacing. That would apply to, see where we see creepage here and clearance. All right, that's explained. We have blind and buried vias. All right, so these constraint modes define what constraints we care about. Now let's actually apply. This is a simple application. Go to Setup, then Constraints. Now, I'm going to expand this. Just know that any constraints we set are immediate when we're using Allegro Constraint Manager or just Constraint Manager. First, let's look at our electrical constraints. Do we need to set anything with the impedance, minimum maximum propagation delay? You would know this for a high-speed design, but we won't really touch that. We have physical, which is the most common. You want to set your default. You may not have this second row where it says power ground, but you're going to have a default set of constraints, and you can expand that. There's the conductor top and bottom, and you can define the minimum line width. So to get your minimum line width, you do a calculation for how much current you need. You say you need your minimum line width for copper of a certain thickness in order to produce that amount of current or to carry that amount of current. And then you put your minimum line width. But also when you're doing that, you check your manufacturer's documentation to see what the minimum they could do. So if they say you can do 6/1000ths of an inch, then I might, and I know my traces can be as thin as 7/1000ths of an inch to carry the current I need, then I might just make it 7.1 or something, you know. But 7 is good. Usually a nice round number is good. For your maximum line width, you put 0 as the max, and then that gets translated to no maximum. For the neck refers to necking down of traces. Whenever you need to take a trace and have it get thin, like if the trace is wider usually when you're routing, and then you need to get thin to get between some pads, that's called the necking down of the trace. The maximum length, well, there's no maximum length, so we'll put 0. For differential pairs, what's the minimum line spacing? That means what distance or clearance needs to be between those differential pairs. I don't know, you put whatever you calculate the values need to be. I'm not concerned about differential pairs here. How much tolerance for that spacing? That is how much further apart can they go and how much further in can they go? Like how strict is that spacing? For vias, we have what kind of via you're going to use. You can click on the via, right? And then choose any of these pad stacks to be in your via list. And you also can get a look at what their cross section and their purpose. So if you double click on here or something, you can add this via to your list of vias. And what this does is when you're routing the printed circuit board, like the layout, and then you choose add via, you can select from this list of vias that pops up. By default, we just have via chosen. I'll just double click on that via and take it out the list of options and then click OK. For a blind and buried via stagger, BB via stagger, that's not something I'm really concerned about right now, but if you're using that, that's where that setting is when it comes to staggering the vias, the blind and buried vias. Allow pad to pad connect, okay. So this is where you set your constraint rules, but they're not applied yet. What you need to do is go to your net, the nets that are on your circuit, and then you can apply reference physical C set. See, it's saying referenced physical constraint set. This is the physical constraint set that we'll be referring to. You can make your list of constraints here. Then in the net section, you can tell each net which constraint they can use out of the defined physical constraint set. So let's say I want my AREF to use the default constraint set. I can do that, you know, because I'm like, yeah, it can have traces that are pretty thin. But if I want power to go through there, I say, you know what? Actually, I want my power ground constraint set applied to my AREF net. And you know what else? When you're looking at a schematic, or when you're designing a schematic, you would put that in your notes so that the PCB layout engineer, whether that's yourself or someone else, knows to apply it to a particular net. Okay? It's very helpful. That's what notes are for in the schematic. And then you have entire regions. Oh, and see how this line width gets applied? So if we power in is set to default, right? But if I change that to power ground, it's a minimum line width. Line refers to the copper trace. PCB Editor calls these traces lines. So a line is this copper. Okay. A trace is the same as a line, as the same as a cline, as the same as a, okay, you'll get used to it. All right, so that's physical constraints. And this goes for pretty much any ECAD software, right? You want to look at your constraint manager because it helps you play by the rules so you don't get in trouble. Okay. And you can define certain regions within Constraint Manager. You know, you can have regions around chips that might be exceptions to specific rules, but we won't get into that. Then for spacing, this is the next big thing. Spacing constraints set. We define groups of rules, sets of rules for our spacing that we need on the PCB. You can have as many of these as you want. Well, maybe not an infinite number, but anyway, you can have a lot of rules, rule sets. And then the line 2, see, we have columns here that categorize the spacing from one object to another object. So, and of course they are going to overlap if you really think about it or get into it. The line 2 spacing says for any line, align to all things, all other things on the PCB will be or shall be 0.008 of an inch. That means from this line, which is also really called a trace, the edge of the line to another line will be 0.008 of an inch or 8 mils. Or the edge of this line to a copper pad edge needs to be 0.008 of an inch. So anyway, line to all things is defined here. Now you don't have to make sure that line to all things is some number. You can get granular with it, very specific, exact. You can do line to line. Okay, that's line edge to line edge, actually. Then we have line to a through pin. A through pin is the edge of this pad on this through pin hole. The SMD pin, that's for a surface mount pad. The line to a surface mount, line edge to a surface mount pad edge. Line to a test pin, line to through via, line to, you get the idea. And then you can double click that to minimize that column. In fact, you can double click on all these columns, right? And minimize them. And you'll only see SMD pin to all other objects, through pin to all other objects, so on and so forth. Okay. Test pin to all other objects. Actually, you'd want that probably to be 100,000ths of an inch for test pin to all other things. That's the recommended IPC standard. You can go as small as, I think, 25 mils, but don't do that. At the very least, do 50 thousandths of an inch, 50 mils from test point to something else, anything else, through via to any other item, right? Oh, let me show you something real quick. It's because I changed that test pin to anything else, all other things to 100. So let's look at line 2, test pin now. If I can actually show you it, let's see here. That got changed. It was 8 thousandths of an inch, but now since I changed the test point to everything else, the line to the test pin only has changed to 100 thousandths of an inch. Very awesome. Anyway, we define our spacing constraint set, right? Now we need to apply them. You go to your net and you say, you know, for my 81 net, I think I want my line to everything else rules to follow the default rules. Again, you can have as many rules as you want in your spacing constraint set. Okay. You can have net classes that follow particular rules. And you would define your net classes in PCB Editor or OrCAD Capture. And then you can have a matrix. You'll have a matrix that shows you all the interrelationships between all the groups of the classes of nets. You can even have regions, specific areas of the printed circuit board of the PCB. You can say in this box over here, I need my spacing to be such and such that is different from the rest of the PCB. Interlayer spacing. This is where things get really crazy. You can have level 1, layer 1 geometries, conductor, this and that. And then you'll see the bend area, like this for your rigid flex. There's a lot of things you can change in here and consider, take into consideration. You check that, but I won't cover that. Then there's same net spacing. Same net spacing. It's important to, I didn't really know that this really existed when I first started using PCB Editor. And I would have potential shorts whenever I'd submit my design to a design for a manufacturer. I'd have potential shorts, potential showstoppers, because I didn't have enough space between one net and another net for thermal clearance of my pads or something. It's the same thing. It's the trace spacing. So this little space in between here. But what happens if the traces belong to the same net? Wouldn't you want to connect them directly so that there's zero spacing? Not always. And that's where thermal relief comes into play. But I won't get into that. But same net spacing is important. Usually I like to set it the same as my regular line to line spacing. Not always, but yeah. Constraint Manager also helps you, well, just directly put in your design for manufacturing rules, design for fabrication, assembly, and test. These come from, ideally, the IPC standard. If you want to know which standard applies to which, you can check in the description below. And you can also get this stuff from your manufacturer. DFM Handbook, okay? Or capabilities of your manufacturer on their website. They'll let you know. Then we have properties. You can have general properties for your nets, like the weight of the AREF. Let's say you want your voltage to be, I don't know, it's 5 volts or something like that. Right. And then once you set it to 5 volts, or whatever volts you want, you can set the weight. Do you want it to be routed or not? Like, do you want to see rat's nest lines? Those are those little air wires. People call them air wires sometimes. And do you want to see those for that net? Do you want to turn that on or off? Do you want the priority? What's the priority level for these nets? Any restrictions you want to apply? Do you want to gloss the net? Do you, as in clean it up as you route or whatnot? Is it Is it electromagnetic compliance critical net? Do you have any special comments on the net? Okay. It can be really overwhelming. I don't spend much time in properties. And then there are DRCs. DRCs can be accessed through the browser. I like the Drc Browser a lot because you can really look at the rules. You can see the errors that come up, and it gives you information. It actually, when you're, instead of sitting clueless about what's going on, what the error means, you can just look there, the outline checks. So you check your outline to trace, let's see. And it even gives you visuals. Okay, very nice. See? Quite handy. And then you can pinpoint the parts of the design that have that error, and then it'll take you there. Let's close that for now. Any constraints you set in here are immediate. You can go to File, export those constraints, and then you can do whatever. Interlayer checks. You can export all your constraints and settings. You can export your technology file. That's the template. You can export your worksheet. You can export your constraints in an HTML file. Okay, you can analyze, audit your constraints. There are many other things you can do with Constraint Manager. But the whole purpose of Constraint Manager is so that you design your PCB and have no surprises, because you're designing by the rules and guidelines that are defined by all the project stakeholders. So by the time while you're routing and you're laying out your PCB, you know you're safe because Constraint Manager keeps your design in check. And by the time you're finished with the PCB, you're good to go. So if this video has been helpful for you, I know it was a long video, please like the video, or feel free to like the video if you actually like the video. If you dislike the video, then okay, but like the video. And also, if you want more videos that give you some tips, pointers that go in depth, that are tutorials, my tips and tricks, thoughts as I go through PCB design experience as a freelancer, and you hear more from me, or if you have any requests, feel free to subscribe to the channel as well. You'll get updates and notifications on when I upload videos. But I think only once you ring the bell, you subscribe and hit the bell, then you'll get notifications of all my videos that I post. All right. For those of you who are specifically interested in Constraint Manager, this is the overall purpose of it. Hope that helps.